مثل احمد فواز، مثل احمد سامی، مثل مستر الله کامل، علا کامل، میسیز دعا، میسیز حنا کاظم، میسیز حنا کاظم again. مثل حسن عباس، مثل انتصار، مثل لبنان، مثل میس، مثل محمد باقر، مثل محمد رشید، مثل نعیمه و مثل نور. I was trying to connect to Skyroom, but my microphone is Skyroom had some problems, okay, and couldn't connect to Skyroom. Salam Mr. Mohammed Bagher. But here we are again in Aid Connect. Excuse me. I uploaded a PDF file for a microcontroller based for AVR. Because was question of one of you, maybe Mrs. Hannah, maybe said about the structure of AVR 80 mega. Okay, in this year, in today, or maybe in tomorrow, we are working about 8051 microcontroller. Okay, that's based of AVR. It's converting and it's uploading. What question about 80 mega 16? Mr. Hannah. Okay, I cancel upload and go to screen my share. Share my screen. Share my screen. OS parameter simulation. Okay, okay. I tell you, Mr. Rashid. Can you see this file? Yes. خب مثل محمد رشید I have a problem with simulation مثل انتصار. Please I installed the code vision but I don't know how to use the program. Just show the program. Okay. That's right. Don't worry. One of you had a question in the last session, okay, about 80 mega 16. I said maybe have some description about the microcontroller. Okay, in this time, today and tomorrow, we'll work over this microcontroller. That's the base of AVRs, okay, or 80 mega. That's right. I disconnect the camera to quality of your web. Okay. To improving the performance of your web. The file is recording. Mr. Mohammed Rashid. Maybe. Okay, start. Have you over this microcontroller? Okay, this microcontroller is based of AVRs. This microcontroller is based of 80 megas. Okay, that's right. It's Zainab. Here, the 8051 basic components. This item, this microcontroller, for example, includes this is the microcontroller. Okay, this IC has a CPU and some peripherals next to it. Okay, for example, some location of RAM, some I/O ports, some timer counter controllers, and for example some serial port controllers. Okay, for example, for this one we have inside it 4 kilobytes of internal RAM, 128 bytes of internal RAM, 4 8 bits I/O port. Okay, port. Assalamu alaikum, Mr. Hamid. مخلص. For 8 port I/O ports, port 0 to port 3. In 80 mega we set to it port A to port D. Okay, DDR-A, DDR-B, DDR-C, DDR-D. Here port 0, port 1, port 2, port 3. Two 16 bits timers or counters or timer counters. One serial interfaces. Here we have one serial interface for UART only. Mrs. Neyman, how do I connect purchase and between code vision? Excuse me. At the end of the class, we have experiment. Okay, for you and for example, Mr. Intisar, for Mr. Rashid, and all of you, we have another execution. Okay, for simulation. But here, please attend to me. Ahsant. Here we are only one serial interface, but in 80 mega, how many serial interfaces we had? We had, for example, 3 serial interface: UART, SPI, serial peripheral interface, and I2C. Okay, here one serial interface, only UART. Okay, that's right. Here, the block diagram inside of this microcontroller. Okay, here see its CPU. All of these items or these blocks are inside the microcontroller. Okay, this is CPU, central processing unit. For example, some spaces for RAM. For example, here 4K of RAM. Here 128 bytes, some bytes, okay, of RAM. Here is maybe 1 timer, 2 timer, or 3 timers: timer 1, timer 2, and timer 3, or timer 0, timer 1, timer 2. Okay, serial port controller or UART. Here 4 ports: port 0, port 2, port 3, port 0, port 1, port 2, port 3, control bus, and here interrupt controller, and some interrupt pins, externally interrupt pins, and oscillator or clock generation block. Okay. In this microcontroller, for example, one on-chip oscillator, 6 interrupt sources. Two of them are external, 3 of them are internal, and reset as a source of interrupt. Okay, 64 kilobytes of external code handling, external code or program memory handling. Okay. That can be activated by PSEN or program select, program store, enable. 64 kilobyte of external data memory or RAM that can be activated by read or write. Code memory can activate or selected by EA, external access. We may have external memory as data and code. Okay. In the next slides, we can see some components of this family. For example, in 8031, there isn't any RAM over it. Okay. In, for example, 87, 51 or 31, we have EEPROM over it. In 89, 31 or 51, we have E2PROM over it. Okay, what was EEPROM and E2PROM? What's the difference between RAM, EEPROM and E2PROM? مثل انتظار. Electrical. سلام Mr. O'Day. سلام سلام. Mr. O'Day, you are in Iran or in Iraq? No. in Iran. ای الله. خب. The work is okay. Mr. O'Day. Oh, okay. Inshallah, inshallah. Inshallah, inshallah. Be okay. Okay. خب مثل رشید electrically erasable پیرام انشالله 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 electrically erasable پیرام okay EPROM means erasable EPROM erasable PROM. Okay, PROM read only. PROM means read only. RAM and PROM means RAM means read only. RAM, PROM, EPROM, and E2PROM. Okay. RAM means read only memory. PROM means programmable RAM for once time. Okay, once time programmable but not erasable. EPROM means erasable PROM. Asantom Mr. Hana. Erasable PROM but by UV, okay, ultraviolet, and maybe about 10 minutes or 20 minutes consuming for erasing the EPROM. But in E2PROM we have electrically erasable PROM. Electrically erasable RAM. That's right. Asymptotic sensor. Electrically erasable. Okay. If, for example, we had 8951 microcontroller, we had E2PROM over it. Okay. Some or say flash or flash E2PROM. The same. Some items of this family, numbering, for example, 80 means Atmel, the vendor, okay, manufacturer. C here means CMOS technology, okay. LV here means low voltage, etc. That's right. Go to the next slide. I go fastly, okay. There isn't any need to deeply learn. Some items of this family, for example, some spaces for RAM, some spaces for RAM, some timers, 2 timer, 3 timer, 1 timer, etc. Interrupt sources, for example, here 6 interrupt sources, here 9 interrupt sources, here 3 interrupt sources. I/O pins. These items means 4 ports, 4 8-bit ports, okay, P0 to P3. But these 2 items have only 2 ports, P0 and P1, for example. What's WD? One of you know what means WD? Oh, here is typed. WD means watchdog timer, okay, for preventing from hanging of the system. Atmel is a company, Asantom, a vendor, a company. ISP means in-system programming, okay, in-system programming. AC means analog comparator. Some features over this elements of this family. That's right. Go to the next slide. This is the internally architecture of this microcontroller. For example, here we see ALU. What was ALU? All of you said previously. مثل محمد رشید، مثل انتصار. احسنتم. احسنتم. Arithmetic logic unit. That's right. احسنتم مثل لبنان. احسنتم. Some temp registers, accumulator, 8 registers, program address, RAM address, RAM address register. Okay, some latches here. For example, we see some buffers, some incrementer. Here we see port 1, port 2, port 0, etc. Go to the next slide. Here it's better. We see port 0, port 1, port 2, port 3. In ATmega we said port A, port B, port C, port D. Okay? For example, port D. We said DDR-D, DDR-A, DDR-B, DDR-C. What was DDR-A, for example? What was DDR? Ahsantom. Data direction. Okay. For example, as input or as output. Port 0, port 1, port 2, port 3. But port 0 is only port 1. Port 1 isn't shared with any other tasks. Okay, this is only port 1. But port 0 and port 2 are shared with 2 other tasks. Okay, port 0 is port 0 and address bus and data bus. Okay, but port 2 is shared with the task of address bus. Okay, the higher level of address bus, A8 to A15. Okay, but here A0 to A7 or D0 to D7. That's right. Or port 0. These are 3 tasks. Port 0, address bus, data bus. That's right. Here we have 2 tasks. Port 2 or higher order of address bus. That's right. Here we only have port 1. Okay. Here we have port 3 or these tasks. For example, these 2 are P3.6 or P3.7 or read bar or write bar. Okay. Here is T1 for timer 1. It's input for timer 0. Is interrupt 1, is interrupt 0. These are receive data and transmit data. For example, if we use the UART controller in our example or design, we need RxD and TXD. But if we didn't use the UART controller, these 2 pins can be released and used as P3.0 and P3.1. That's right. Ms. Lobna, I said these 4 ports, port 0, port 1, port 2, and port 3, are shared with other tasks. Okay. Ports are shared with some other tasks. Okay. Port A, port B, port C, port D, or port 0, port 1, port 2, port 3 are shared with some other tasks. Okay. Here maybe you have a port 0 or maybe address bus A0 to A7 or maybe data bus D0 to D7 Here port 2 maybe act as port or act as address bus, okay, A to A15. But port 1 is only port 1. Here port 3 maybe some pins of it may be used for some tasks. For example, P30, PT1 may be used as UART controller pins, okay, receive data and transmit data. P3.2, PT.3 maybe used for interrupt 0 or interrupt 1. For example, in our system, if we didn't use it at interrupt 0, we can use it at P3.2, okay, etc. Timer 0 input, timer 1 input, read bar, write bar for hand checking with RAM memory, okay? Okay, Mrs. Lobna? Ahsant. And here's a crystal, okay? For example, some crystals, 12 megahertz crystal is installed here, and some capacitors as data sheet recommended to us, okay? Here's VCC and ground. Go to the next slide. The pin outs in another landscape. P0, P0.0, P0.1 to P0.7, P1 port 1, P2 port 2, and P3 port 3, okay? P0 may be used as address bus and data bus 0 to 7, etc. As the last slide. Okay, Mesode. I say this is address latch enable. See in the coming slides. Address latch enable or program for programming the EEPROM. External address, VPP for erasing the EEPROM. Program store enable. Reset and install1, install2. P2 is analog? No. P2, no analog. Address bus. Mesela انتصار. Address bus. P2 is P2 or address bus. Okay, higher score of address bus. High byte of address bus. P0 maybe port 0 address bus. P0 port port 0 or address bus or data bus, okay? 3 tasks. Port 0 may be used as port 0 or address bus, lower byte of address bus, or data bus, okay? 8 bits data bus. Port 1 is only port 1. Port 3 is shared with some tasks. Asynchronous sensor. Okay, go to the next slide. Here are some descriptions. Port 0, 8-bit read and write general purpose I/O, or acts as a multiplex low byte address and data bus, as said, for external memory design. Okay, maybe if you use the internal memory, there is a use for using address bus and data bus. Okay. In some maybe in almost tasks of ours, there isn't any need to external memory, external RAM and external RAM. Their address bus and data bus isn't used, and we use it as port 0. Okay, port 1 only 8-bit read writeable general purpose I/O. Okay, port 2 8-bit read writable general purpose I/O or high byte of the address bus for external memory design, okay, for external memory only. And port 0, general purpose I/O, 8 bits of read and writable general purpose I/O. If not using any of the internal peripherals, for example timers or external interrupts, okay. Each port can be used as input or output. That means it's bi-direction. You use as DDR, for example, data direction of port A, port B, port C, D. Go to the next slide. And these are some other tasks. Our port 0, receive data, transmit data, interrupt 0, interrupt 1, timer 0, timer 0 external input, timer 1 external input, read bar, write bar, and read bar, okay. External data memory, write strobe or write enable, external memory, external data memory, read strobe or read enable. This is a structure of ports, okay. We have some problems for reading from the pin or from the latch, okay. This is a structure for reading from here, this buffer and this buffer, read from latch and read from pin, okay. Maybe for isolating this internal bus and this side, okay. For example, maybe this port is connected to base of a BJT, or for example connected to a relay, okay. This structure is necessary for isolating between these two sections, okay. This D flip-flop. This is the work of this item, and this is a good item. What was this item? The synthesizer. Can you send us? Oh yes, the synthesizer. Yes, after the class. This item is for pull up, okay, pull up resistor, pull up resistor, okay. Go to the next slide. I explain fast. Each pin of I/O ports internally connected to CPU bus, a D latch stores the value of this pin. Write to latch 1, read pin 1, read latch 1, transistor gate 0 open, gate 1 close. Here, this is the gate of this MOSFET is has gotten from Q bar, okay. For example, when you type here 1, here after the clock is here is 1 and here is 0, okay. When here is 0, this is connected to ground. Here is 0, the MOSFET is turned off, and here is 1, okay. This is what it was. This pin what 1 was 1, and this drain pin is to 1, okay. This structure is constructed for isolating between this pin and this internal bus. That's right. Some description for the work of this pin that you can read after you got the file I passed from these items. Oh, here. This is pull-up resistors, okay? These pull-up resistors are inside of the port, inside of the microcontroller, okay? For these microcontrollers. These are inside of this microcontroller. And by simulation or by software, you can use these resistors, okay? Or disconnect them. Some pins, PSEN means program store enable for using external RAM. Okay, ALE means address slash enable. We see it in the next slides. EA means external address, external access enable. Receive data and transmit data for using UART controller. Crystal using Crystal. Okay, this is the Crystal connection. Another use of the Crystal connection using external oscillator signal constructed anywhere over the board. For example, computing some machine cycles. For example, if we had installed as 11 megahertz or 16 megahertz, okay, find the machine cycle for these items. For example, in this microcontroller, each machine cycle consists of 12 clock cycles. Okay, that means this frequency is divided by 12. This is the resultant frequency, and machine cycle T is 1 over F. Okay, machine cycle means 1 over this item and about 1 microseconds. But when the crystal was this item divided by 12 resulted megahertz, and machine cycle means about 3/4 of microseconds. Okay. RST means reset, input pin active high for power on reset. That's right. Here's the circuitry for power on reset. Because reset is active high. Okay, when you connect the VCC or battery, the capacitor is fastly charged, and this item is go to VCC. Okay, and this is activated. But this circuit, this RC circuit, this circuit from VCC to ground, okay, from ground to VCC, then to capacitor, then to resistor, and then ground. This circuit, this is a RC circuit. Okay, the first order RC circuit, and resistor is the capacitor is discharged in this RC circuit. Okay, and for example, some microseconds based on data sheet, some microseconds this pin must be activated or be in high voltage. Okay, to our microcontroller is in a reset situation, and this two item is for crystal connection, and maybe allow external access is deactivated. This is a external access bar. Okay, and connected to VCC. That means there isn't any external access. This circuitry in this slide, we see this circuitry, and this push button. When you pushed this push button, the VCC is connected directly to this pin or to this pin. That means the microcontroller will be resetted. That's right, by pushing this push button. Go to the next slide. Here, reset value of some microcontroller registers. Okay, what means PC here? Mr. Ahmed, what do you say? صائم. أنا صائم إن شاء الله. عرفت. مسا صائم. مسا صائم. مسا حامد. إن شاء الله. ما منكم. منا كلنا. PC means program counter. Okay. ACC means accumulator. B, the secondary register. Okay. PSW means program status word register. SP means a stack pointer. Some registers inside microcontroller. Okay. DPTR means a data pointer. Okay. And reset value, all of them are in as 0 except of a stack pointer. Okay, that is reset to 7. I say in next slides. Okay, all of RAMs are reset to 0. EA external access. There is no on-chip RAM in this item and this item. The external access pin is connected to ground to indicate the code is stored externally. Okay, for external access. Program store enable bar and address latch enable are used only for external RAM accessing. For this item, external access bar pin is connected to VCC. Okay, for deactivating this pin. This means bar. Program store enable. Okay, this is an output pin and is connected to the output enable pin of the RAM. Address latch enable. Here I read it's an output pin and is active high. Okay, port 0 provides both address and data. Okay, port 0 address bus and data bus. The address latch enable pin is used for demultiplexing the address and data buses by connecting to the G or gate pin of this latch. Okay, this is a latch IC. Or 8 D flip-flop here. Address multiplexing for external memory. Here, maybe here. This is the microcontroller. Okay, this is the microcontroller, and this is EEPROM, for example. Okay, external memory. The port 0 is port 0. Here it is address bus and data bus. Okay. Address bus and data bus. This is AD0 to AD7. But this side, this is A0 to A7. That means address bus. And here is data bus or D7 to D0. But for separation, we use ALE. ALE means address latch enable. Address latch enable is as output, okay, from microcontroller to this latch. Okay, 373. Okay, here, and this is port 2, or here as address bus A8 to A15, and these two items are all of address bus A0 to A15. Okay, and these 8 items are data bus. Okay, but these tasks I come back to this item. The timing for demultiplexing of address bus and data bus. Okay, address multiplexing for external memory, multiplexing and demultiplexing. Here is for example, non-multiplex maybe, for example, for Motorola microcontrollers. Okay, and multiplex versions for Intel microcontrollers. Okay, or Intel microprocessors. In non-multiplexed, for example, maybe from PowerPC or Motorola, here is only address bus. Okay, A0 to A15 address bus, and this is only data bus. That's right. Two separated buses, address bus and data bus. Here data bus is 8 bits and address bus is 16 bit. That's right. But here, this is our story. Here, multiplex version, or in Intel families. Okay, all of Intel families. Address bus and data bus are shared in time. That means time sharing. Okay, I type time sharing. for using some less pins. Okay, here this bus is separated, only address bus A8 to A15, but this item is multiplexed. That means in sometimes means address bus A0 to A7 in this time. Okay, and in this time means data bus D0 to D7. Okay, for example, you can buy an apartment in, for example, in Mashhad in Iran, or in maybe we can buy, for example, inshallah, in Iraq, in Karbala, maybe an apartment. Okay, maybe you buy for all of times. Okay, or maybe you buy a week per year. Okay, this means time sharing. That's right. Here only 8 bits for 2 tasks. In this time, this pins means address bus, and in this time this pins means data bus. Okay, for lower byte, 0 to 7, but for higher byte only we have address bus. Okay, in this slide we see the this timing. What about address latch enable? Address latch enable is very critical, okay, for separating these two buses. Here, for example, read timing for external code memory, okay, a machine cycle, one machine cycle from here to here, okay. Each machine cycle consists of some cycles, some states. State 1 to state 6, okay, and each state consists of 2 phases, phase 1 and phase 2. Okay, here phase 1 are S1, phase 2 phase 1 is S2, phase 2 of S2, etc. Here for reading, okay, for reading from code memory, okay, that means fetching the instruction. I type instruction fetch, okay. First of all, CPU activate ALE, address latch enable, okay, and program store enable is deactivated. This is active low, okay. Here program store enable is deactivated. Port 2 A to 15 here is activated when you deactivate this address latch enable here, okay. Over the bus we see PCH, okay. All of time we see PCH. That means high byte of program counter. That's right. What about this? In this time, our port 2 we see PCL. That means lower byte of program counter. That's right. But here, in this time, for example, P2 of S4. Okay. After some delays to this time, me as CPU get the opcode from the memory, from the RAM. Why? Because this pin was activated for some times. What is this? Program store enable bar. Okay. After this time, lowering these pins means read. This low voltage means read from RAM. That's right. And in this time, from here to here, the RAM memory tries to put this opcode, this data over the bus, okay, and me as CPU get this code from the bus. Okay, thus this shared bus means opcode or data. PCL, I said PCL means program counter lower byte of program counter. Okay, lower byte of PC or program counter. Here we see only PCH, but here we see two items, PCL or data. And these two items, PCL and PCH, means all of address bus, but here we see data bus. Address bus, data bus. Address bus, data bus. Okay, as said in this slide. In this slide, address data, but this is only address. Okay, that's right. This connection for separating between address and data bus from port 0 and connecting address bus to address bus of external memory, for example RAM, and data bus to data bus of external memory. Okay, and all some items. Param store enable is connected to output enable of RAM. Okay, for reading from the RAM. Here, accessing external data memory. This slide was for external code memory from EEPROM, okay? But in this slide, accessing data memory, that means RAM. Here is a RAM, okay? Data memory is stored here. Okay, but again, we see port 0 is separated to data bus and address bus with using address /enable and a latch beside the microcontroller. Read bar and write bar is used instead of program store enable. We don't see any program store enable here. Okay, program store enable not connected. Is using when we use, for example, RAM. Okay, for using RAM, we use these two pins, read bar and write bar. That's the read bar is connected to output enable of RAM, and write bar is connected to write bar. Okay, what is this pin? This pin is chip select. Okay, chip select bar that we see is connected to ground for activating this chip. Okay, when we use some chips, okay, this item means not here. For example, chip select 1, chip select 2, chip select 3 in each time isn't connected to 0, to ground. For example, may be connected to P2.2, for example, or the chip select of another RAM is connected to P2.3, etc. Mr. Ahmed, what do you say? Oday يفتر يمكن? Oday, Mr. Oday? What do you say, Mr. Ahmed? يمكن Mr. Oday is okay. Mr. Oday is gone for iftar, you say? This time? No. Mr. Oday is time or no, not in Iran? صائم. but we have some hours to iftar. بس Ahmed. In Iran, about 1.5 hour. استاذ عباس. نعم. In Iran, over 1 hours to iftar. Sare? Oh, Sare for iftar. Okay, for family. نعم. فطور يمكن. I don't know. يوم كم؟ يومك كم؟ عندكم عندنا؟ لا أنا في العراق بس أودي in Tehran. About 3 or 4 hours between us. Miss Noor? Mr. Uday in Iran, but in Tehran. I'm in Iraq. About 300 kilometers from Iraq to Tehran. خان میبینم. اوکی. Miss Ahmed, أيوم كم? What means يوم كم؟ يومك كم؟ يمكم؟ فطور يمكم؟ مثل لبنان يمكم عندكم. يمكم يجي عندكم maybe. لديكم maybe. If Masoudi come to our home, نحن نقول تفضل شكرا. أهلا وسهلا. مسعودي ما زوجته in Iran. نحن نقول أهلا وسهلا. جاء في بيتنا. in Iran we say قدمت بر چشم. رجلك على عيني. اي نعم. تعبت or تعبت. Okay. Where's Masoudi? Are you in the class? Or not? Maybe not. Masoudi is coming and going. That's right. What do you say? We say in Iran, رجلك على عيني. What do you say in Iraq? You say قدم بر چشم. Maybe رجلك على عيني. تفضل في بيتي. تفضل عندنا. ارحل عندنا. What do you say in Iraq? رجلك على عيني. أنت راغي. أنت. مسامد. Miss Noor and Mrs. أهلا وسهلا. Okay. أهلا وسهلا. What about this item? رجلك على عيني. قدم بر چشم. أنت على رأسي. Maybe. انقطاع بين فراش. جيتك على رأسي. جيتك على رأسي. لغست حياك الله على رأسي. In Iran we say قدم بر چشم. قدم ای رجل بر علا چشم عین. رجلك على عینی. رجل no رجلك على عینی. لكم رجلكم على عینی في ایران. Maybe after corona all of you رجلكم على عيني في إيران في بيتي. أهلا وسهلا. مساء مخلص میزنم. مخلص مخلصیم. مخلصیم. ممنون. مثل عباس. مخلصیم. خب خیلی متشکرم. احسنت محمد باقر. شکرا. مخلص Mrs. Noor. احسنت. Here. I said in connecting to RAM. Okay, in connecting to RAM, we don't use program store enable, but only use read bar and write bar. Okay, read bar for reading from RAM. Mr. Ansar said, please tomorrow we have the advanced exam. And we want some time to read. Okay, what this time? Okay, less than half an hour. Okay, Mr. Entisar. About a quarter. Okay, Mr. Entisar. Okay, that's right. About a quarter. But okay. Go to the read bar is for reading from the RAM, and write bar writing to RAM from CPU to or microcontroller to RAM. Next slide. Here, timing for move X or move external. Moving data from microcontroller to difficult exam. Okay, who is your teacher, your professor? Mrs. Neyman or Mr. Ansar? Who is your professor? Dr. Shakur. Okay. That's right. Advanced software. Okay, I know him. What advanced? Advanced programming, advanced software, advanced OS. What's your lecture? Oh, advanced discussion. صدا هست. صدا هست. You hear me? All of you? مثل باقر. Please go. I must type. What about our class? Aha. Aha. Okay. Okay. Don't worry. Maybe class تعطيل or another one. I don't know. Really, I don't know. مثل یاسر علی مثل ابتسام are typing تعطیل. You say Dr. Mohammed. Dr. Mohammed means Dr. Mohammed Shakur. You said in Telegram Ustad Mohammed. Dr. Shakur. We say Dr. Shakur. What? Mr. Yasser. Yasser Ali. What? Yes, can you cancel? Maybe. There's no problem. Don't worry. Okay, Mrs. Noor. Okay, Mr. Ahmed Sami. Okay, don't worry. You prepare for your exam only. Okay? You are in you are Saim or Saimeh, and you have exam, but there isn't any need for the class. Okay? No. That's right. That's right. Okay. Class in tomorrow is تعطيل. Okay? You say in Iraq تعطيل? In Iraq, what do you say? In Arabic. In Iran we say class تعطيل. In Arabic what do you say? تاجل? عطلة, معطلة, عطلة, تعطيل. We say تعطيل. مخلص. This is لبنان. مخلص. مخلص. عطلة. مثل ابتسام. عطلة. We say تعطيل. به وزن تفعیل. مخلص. تعجلت. مخلص. مرسی. فرانسوی. فرانس. Okay. That's right. خیلی ممنون. مخلصیم. کلاس فردا تعطیل. کلاس غدا عطله. Okay? کلاس غدا عطله. Only your exam. Multiple attendees are typing. انشالله. شکر. مخلص. Mrs. صفا سلام. مخلص. مثل الله هاشم. مخلصیم. That's right. Next up class. Continue. مثل ابتسام. مخلصیم. مخلص. مثل ابتسام. Mrs. Noor is typing. Mrs. Naima is typing. What do you say? ألف شكر. أنا أقول بكم 100,000 شكر. خوبه؟ 2000 شكر. نايمة. ميسي نايمة. 2000 شكر. أحسنتم. Okay. Here. Okay. Here we said for example for this instruction move x. In this time we have a fetching cycle, and in this time we have a reading cycle. Okay, but reading from RAM, here reading from ROM, but in all of them in all of them. Port 2 is used as PCL, PCH, that means a higher byte of param counter, or DPH, that means higher byte of data pointer. Okay, but port 0 is time sharing. PCL here data, opcode, this is address, this is data, this is address, DPL, data pointer low, this is data, in read bar, in read cycle, this is external data in. Okay, PCL, etc. In this slide we said that P2 and P0 are some tasks, they have some tasks shared beside P0 and P2. Okay, address bus and data bus. In P2 we only have address bus beside port function. In P0 we have three functions, three tasks: port 0, address bus, and data bus. Okay, go to the next slide. Here, excuse me, here, in other landscape, external code memory, this is a RAM and this is a microcontroller. Address latch enable is connected to G pin of the latch IC. Port 0, here is AD, address and multiplex of address and data bus, but here is demultiplexed. Okay, here is address bus, here is data bus. Okay, but using this pin, address latch enable, that's right. For handshaking with RAM, we use this pin, program store enable. Program store enable bar is connected to output enable bar. This is a chip select. Chip select bar is connected to ground, and here is a lower byte of address bus A0 to A7. Here is higher order A8 and 815 to 815, that connected to P2. Okay, external address is connected to 0. External address bar, external address active low is connected to 0. Why? Because we are handshaking with this RAM. Okay, this external RAM, that's right. Go to next slide. Here we had external code memory in this slide, that means handshaking, interfacing with RAM. But in the next slide here, external data memory, that means handshaking with RAM. Okay, instead of param store enable isn't used. Okay, instead of it we use read bar and write bar. Write bar is connected to write bar of RAM, read bar is connected to read bar of RAM. Chip select is connected to ground, as the same. Address bus A0 to A7, A8 to A50. A0 to A7 is connected to output of the latch, and this item is connected to port 2. That's right. And here's the address searchable, etc. Next slide. Overlapping external code and data spaces. That means a RAM can be used as data or as code. Okay, for increasing flexibility. You can use this structure. Write bar is connected to write bar of RAM. Okay, maybe for code or for data. But for read bar and param store enable, okay, are multiplex in a NAND. This is a NAND gate. Okay, in a NAND gate and connected to output enable. That means each of these two items, that means read from RAM or read from ROM. Each of these two items that's activate this output enable. Okay, that all of this item means that you can write in this area as RAM and read from it as RAM or as ROM. That means for for example, what do you say? Reconfigurable system. Okay, here a reconfigurable system. Okay, here a reconfigurable system. Here, what was it? Here, that's right. But here today's we have a item as ISP. ISP means, what was ISP? مثل محمد رشید، مثل انتصار، مثل صفا، مثل الله هاشم، مثل ابتسام، مثل نعیمه. All of you. مثل حلا. I see here all of you. 22%? 23%. It's low. What about all of your friends? Where are others? You may be over than 40%. مثل احمد فواز، مثل الله هاشم، مثل الله کامل، میسیز بایدر، میسیز دعا، میسیز حلا، میسیز حلا دیگه، مثل حامد، میسیز حنا، کاظم، مثل ابتسام، مثل انتصار، مثل لبنا، مثل ماجد، مثل میس، مثل میس، مثل محمد رشید، مثل مصطفی، مثل نعیمه، مثل نور، مثل اودی. مثل اودی, are you here? مثل اودی، مثل صفا، مثل سعدت، مثل سرا. I said in Telegram I said تحت السرا, okay, but maybe Mr. Abbas corrected me. تحت الأرز. تحت الأرز is corrected. Correct. Oh نعم Mr. Uday, أحسنتم. فكرت أنتم الغائب. Mr. Uday. Okay. What is okay? I'd say other ones. Mrs. Sarah, Mr. Yasser Salam, Mr. Yasser Ali, Mrs. Zahra, Mrs. Zahra Mohsen. مخلص. نحن مخلصين له الدين. Mr. Uday. Okay, I send PDF for you. This is name. I send PDF for you. Mr. Uday, in Iran, in fun, we say مخلصين له الدين. أي مخلصكم. Okay? Mr. Ali Abdul Abbas, Salamun alaikum wa rahmatullah. This is the end of class. Mr. Ali Abdul Abbas. What means Dr. Fatur? Mr. Uday? I don't know. أنتم فاتور؟ أنتم صيام؟ أنت or أنا؟ كلنا صائم. كلنا صائم. إن شاء الله قبول. Time Fatur in Iran? No. Time Fatur in Iraq? No. In Iran? No. This is Safa. In Iran. About 1 hour later. In Iran, 1 hour later. In Iran. But in Iraq, 1 hour and a half. Okay? In Iraq. Time of Fatur. Mr. Uday say time is for Fatur. Near to time of Fatur. Okay. Maybe. That's right. What Mukhlis? What was ISP? ISP. What was ISP? Mr. Rashid. No, no, no. أحسنتم Mr. انتصار. ISP is Internet Service Provider. Okay. But here, as Mr. Ansar said, ISP here is in system programming. Okay? Or in system program well. Okay, in system programming. When ISP protocol wasn't موجود, okay? You can use this architecture, okay? But here, today's, we have ISP, and there's any need to this item, okay? This file is for previous years. That's right. I promise you to terminate the class, and this is the end of time for this time. Okay. Oh. To this slide, maybe okay. Isn't any problem? I share this file for you in Telegram, inshallah. Oh, مخلص مسعودي. Pass my salam to your زوجتك. أرسل my salam. أرسل سلامي. بلغ سلامي بها. مسعودي. Inshallah. What Mr. Rashid said? خانم سلام. مخلصين. قل مخلصون. نحن مخلصون. اي نعم. مخلص. ان شاء الله مع السلامة ومع التوفيق. مسعودي ان شاء الله مع السلامة ومع التوفيق.